Hello, this is a 256 channel scalp EEG recording. It was performed with an EGI system, and this is opened in the native format in Persyst. And this is a very short ad hoc screencast just to show how to apply a channel map and how to process the recording in Persyst using settings for 1010 and 1010 channel maps, specifically for the EGI recordings. This is Michael Guess, I'm VP of Research and Clinical Applications for Persyst. Let's go ahead and get started. This recording's already been processed. I have another one as well. Important thing is, if a recording is already processed, you can't change the channel map because the channel map and the channel lists are applied to specific trends. And so a channel list is essentially a collection of channels. And so these are the 1010 inputs for left and right spectrograms, for rhythmicity and so forth. And the spike detections are set up to indicate the rate of detections based on the 1020 and 1010 labels. And this settings file, if we go to here to preferences and trend preferences, this one is trend settings version P14 1010.mmx. So how did we get here? Let's have a look at the process. So after opening the file, and doing that, we just select open and select the EGI file type and browse that location. Now, if the file is on a network location, the speed of that network location is going to be important because there's a lot of access to that recording during processing and during review. You may want to copy the file to your local hard drive to do processing analysis, unless you're running on a very fast, low latency network, because it is data intensive, especially if you're sampling at a kilohertz. With 256 channels. It's just a good amount of data. So to do a channel map, first I'm just going to have to clear the trends, and normally you won't have trends already processed on this. So I went ahead and cleared the trends. I'm going to select to display the EEG only, because if I have the trends displayed, again, those are loading anticipating channel maps and channel lists. Channel maps are basically taking an amplifier input and mapping it to a channel label. So to keep those out of the way, we're just going to click the EEG page, and I'm going to zoom in on the trends. Right now we're showing the recorded montage, which is the input. And so to see what's going on, I'm going to select the all button. I'm going to zoom in. These already have 1010 labels applied, but let's go ahead and see where that's done. We click the recorded button. We'll go to recorded headbox channels, and here we've applied an EGI 256 extended 1010 ray label 1. We've got a few different ones. If you install the Persyst 14 with the 1010 settings, it'll include these channel maps. And you can see we have ones for 256, 128, 64, and 32 channels. And you can pick the 256 as well. Some of these are the extended 1010 labeling that was developed at Beth Israel. And so I'm just going to go ahead and pick this one. And what this does is apply these labels. Now, what you normally see are numbered inputs. And that's something important to keep in mind, is in EGI, in the Mac software, you can do what's called montage operations, which can downsample the recording, remontage it, change the reference. Ideally, you don't want to do any of that. You just want to get the raw recording without labels applied to it, because you can apply the labels here. And that saves some steps, and it also makes it predictable, because depending on where the reference is placed, that can affect other things. So we know these channel maps will line up properly based on the net that's used. So go ahead and just apply the maps in Persyst for that. And so I just pick this one, and then you pick apply, and it'll applies those labels. And you can see when I reduce the number of channels here down to 48, I get a vertical scroll bar. I can page up and down through this list and see that they're all looking okay. Now, to process it, then you can show the trends. Once you've applied that channel map, you go ahead and bring the trends up if you want. And the next thing to do, once that map has been applied, and again, we go to recorded headbox channels, that's the map that's applied. So let's go ahead and pick under trend preferences, version P14 1010. If we go to the channels list, this is using a bipolar longitudinal trend 1010, and those are the channel lists that are in this, grouped by different anatomical locations. So we'll go ahead and click OK here. and then we'll click process, and the recording will begin processing. Now, of course, a lot more data here. So the volume of channels, of course, is multiples of a 1020, and it will take a little bit longer to process this than it would, or you'll see the paging speed for processing will take a while longer. Once it gets going, it'll go about 5 or 6 minutes in. It'll calibrate some of the detectors, and then it'll continue on with that process. It's also applying artifact reduction to all the 1010 inputs. So if it's a scalp channel and it's 1010, it'll apply artifact reduction automatically, and you can toggle that on and off. It's also doing spike detection as well. And if I go ahead and pause this, and I have the research package loaded so I can look at the calculation engine parameters. I'm going to go to preferences, trend preferences, calculation engines. If you have just the clinical package loaded, you won't see this part of the interface. But if we go to the spike density engine and view, we can see that it's using the 1010 average 12. So it's using an average 12 reference and including all the 1010 inputs as well. So that's how to process it. Apply the channel map, and then go into preferences, trend preferences, click open and select the trend settings version P14 1010, and then you click process. Now once that recording has been processed, you'll see the full set of trends. I've also exported some detections using vplot groups, but in any case, here's one of the detections, and just showing a 1020 montage. As part of the 1010 installation, you also get 1010 montages. Here's a 1010 average 12. This one's interesting. This is a 256 channel CZ overlap, so it's a CZ reference. And if we go ahead and reduce the number of channels here so we can zoom in a bit, what's been done is the adjacent channels have been overlaid. So you've got 3 channels, sometimes 2, sometimes 4, but they're all adjacent to each other. And they've been laid one on top of the other. So if you have a high resolution screen and you're spreading the channels out, what this will allow you to do is to view all of the inputs in that 256 channel recording and show them in their entirety. And that's the reason why I picked that Beth Israel extended 1010 nomenclature, is that would also allow you to use this full 256 channel montage overlapping adjacent channels. This is one way to do it. You can also look at the recorded montage, which again is just CZ reference. That's how the channel map is set up for this, and view all of those channels. And of course we have standard ones like average 12, and there's a bipolar one installed with that as well. And if we go to spike review, and I've already launched it here for brevity, spike review, if it loads with the Laplacian montage, go ahead and select any of the 1010 montages. Now what it's doing, and this is part of that consideration of network, this is going and is pulling out 1 second chunks of, or segments of the EEG at each spike detection and averaging those to display those averages in groups. And if you have a higher latency, slower bandwidth network connection to that file store, this could take a while to load. So having it on a local drive will definitely speed up that process. And again, just like using spike review for the 1020 recordings, you double click on an average and you can go into that average and look at those. I'll go ahead and change the gain. You can look at these detections and then decide if these are real or artifactual. And you can zoom in a little bit more, look at the at a 5-second glimpse of that, or you can click the hyperlink at the top of each one of those detections and it'll take you to that point in the EEG. And if we page up here, we'll go ahead and see that detection there. That's a very quick overview of the process. Any questions, feel free to email or call. Again, this is Michael Guest, VP of Research and Clinical Applications for Persyst. Thanks for watching.